farmer wins payout after trigonometry proves that hot air balloon caused fatal stampede. A pig farming firm that sued a hot air balloon company, claiming one of their flights caused a fatal stampede among their animals, used a maths professor to win a $40,000 payout. The insurers of the company providing the balloon ride used the GPS data generated during the flight to claim the balloon did not come closer than 750 meters from the pigs, and so could not have caused the stampede. A university maths professor used trigonometry methods to prove their case. Professor Chris Fuster from a math department of University of York said that the hot air balloon was 300 meters from the pigs, a far cry from the 750-meter claim of the hot air balloon company. What he did was he used the picture attached in the email and figured out the location of the balloon. He based the location from the lie of the land and the height of the trees surrounding it and the size of the method he used was not specified, but I can only guess that he used the triangle and the trigonometric functions to prove that the hot air balloon was actually really close to the pigs, close enough to scare them away. So through trigonometry, Chris was able to help the pig farmer prove that they were wronged by the hot air balloon company, and they receive a $40,000 payout.
Trigonometry is an area of mathematics that covers the properties of a triangle. One example in which trigonometry can be applied on real life is in aviation. The law of sine, cosine, and tangent, as well as the angle of elevation and depression, have all been used in aviation. An airplane needs the use of trigonometry in order to function well. Whenever an airplane approaches the airport, the pilots must visually maneuver the airplane, and with that, a stabilized and smooth approach would be made towards the runway. To know and find the exact angle of descent and ascent, or angle of takeoff and land, and to find and maintain speed, velocity, and wind speed. To know and find the exact angle of ascent and descent, or the angle of takeoff and landing. And to find and maintain speed, velocity, wind speed, and direction. The importance of trigonometry in aviation might not be evident or visible to some, but without the presence of trigonometry, the aircraft might end up crashing and might cause passengers injuries or worse. It might cause death of passengers. Oh, should I state the source?
More clues about where to search for a possible ninth planet lurking in the borderline of our solar system are emerging from the Kuiper belt, the icy debris field beyond Neptune. New calculations suggest that the putative planet might be brighter and a bit easier to find than once thought. Their oval orbits all point in roughly the same direction and line in about the same plane, suggesting that a hidden planet about 5 to 20 times as massive as Earth led them into similar trajectories. As reported by Brown and Batugin, Planet 9's average distance from the Sun is most likely between 500 and 600 times as far as Earth's. The planetary scientists use trigonometry to calculate the distance of the planets, stars, and other objects in space. They mainly apply the topics about angles and triangles to determine the interval between space objects. About where to search for a possible ninth planet lurking in the borderline of our solar system are emerging from the Kuiper belt, the icy debris field beyond Neptune. New calculations suggest that the putative planet might be brighter and a bit easier to find than once thought. Their oval orbits all point in roughly the same direction and line in about the same plane, suggesting that a hidden planet about 5 to 20 times as massive as Earth.
To determine how forces affect buildings, engineers use right triangles since forces pull and push buildings at different angles. The magnitude and direction can be represented as vectors. It serves as the hypotenuse or right triangle. Magnitude can be divided into vertical and horizontal components. By doing this, they can see how forces will affect their buildings. Engineers designed the Grand Canyon skywalk by understanding how it will be affected by gravity, the weight of visitors, high winds, and even earthquakes surrounding the area. The final product can hold 800 people and can withstand an earthquake measuring 8.0 magnitude on Richter scale and can also land 71 Boeing aircrafts on it without collapsing.